Okay, so what I've done here is I've modified the bisection uh, uh, notebook that I had put up in order to in this module. And so I'm from NumPy, instead of the functions I had been importing, I'm importing tan because we're going to do a tangent function. I'm doing pi because we'll need that. I'm doing linspace. And I'm going to do a graph here. Okay, so I set up this stuff that we'll need to help us with the graph. And so I shift and enter, and there we go. And I take the bisection like I had written there. I don't change it any. But here in the original one, I just I change, instead of using Kepler as the name for every function, I changed the name of the function to problem 1a, which will help us identify which problem from computer assignment 3.1 we're doing. So this is, and instead of using the asterisk negative exponent, I use 1 divided by x. I mean, that wasn't the problem with yours, but whenever I have a chance to use a division instead of a negative exponent, I do it. And see, what I want to do here, I want to get a graph of this function, because as you noted, or as you will find if you just try to work this straight, you can't divide by 0. You get errors if you divide by 0. And there are workarounds, but let's approach this and to get a graph and see where the problems are, because graphing is one of our big tools. And so with my 1 over x, if I start out with 0, I'm going to get a problem right away. So I'm going to back off by 1/10. And with my tan, if I just put in a pi over 2, that's going to give me a pole as well. And so I back off of that by subtracting, again, 1/10 from it. Okay. And so here, I'm going to graph this function and then plot it, and then shift and enter. And okay, here we go. Okay. And so there I can, I see that, yeah, I become infinite and negative infinite at the ends, but I am going to have a 0, somewhere, it looks like somewhere between 0.8 and 10, excuse me, and 1. Now, here I had put a max y here because in a previous version I was going to see how it worked. Here I'm just going to cut that cell out to show basically. I could have just backspaced over it, but you're going to probably want to cut out some cells from the original thing. Now I do, okay, bisection, and I'm going to start. Yeah, I could do 0.1 to pi over 2 minus 10, but why don't I, since I can read this from the graph, sort of do a 0.8 to 1. That'll give me kind of a head start on the process. And okay, I'm going to not want to do this any more than 100 times. And I'm going to choose my delta to be 1 e minus 10, my epsilon to be 1 e minus 10, and my function to be problem 1A, A. Okay. Let's see if this works. Oh, and I get an error. Okay. All right. I do need the sign up here. So I go SIGN and I go enter, 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 enter. And let's cross our fingers, enter, and there we go. Yeah, my root is between 0.999999 and 93. So, interesting. Let's see. Let's just return. Okay, I'm going to pause for a moment. Okay, I figured out that this is, I'd forgotten my own function. What it returns is the C is my approximation of the root, and the E is my approximation of the error. And so we're good.